This tutorial is for linked list introduction. In this tutorial, we will see what is linked list and what are the types of linked list. But let's first discuss why do we need linked list. Let's suppose you have hundreds of employees in an organization and you need to store salary of this employee in an array. What will you do? You will pre-allocate the memory for 100 employees in array and then store salary into it. But what happens when 10 new employee enters into the organization? You have nothing in arrays to increase the size. But in case of linked list, we have runtime memory allocation. That is, we can increase and decrease the size anytime we need. This concept is called dynamic memory allocation. And because of this concept, we never have wastage of memory and we never have shortage of memory. This is the definition for linked list.
I don't understand.
Don't worry, we are going to discuss this point by point. Our first point, linked list is a linear data structure. What is linear data structure? So linear data structure arranges the data in sequential manner, while in case of nonlinear data structure, it arranges data in hierarchical manner. So some examples of linear data structures are linked list or arrays, and for nonlinear data structure it can be trees. Now let's imagine our linked list. How is it going to look like? So just imagine a train with some coaches behind it, and we have to assume our coaches with nodes. Now let's see what is the nodes. In linked list, nodes are having two parts, data and next pointer. Data stores int, string, float or anything you want into it. But next is going to store the address of next node, just adjacent next node. You can see here first node is storing the address of second node. Second node is storing the address of third node. This goes on till end. Because of this next pointer, one node is linked to the other node. In linked list, this is the first node's data part and this is the address of second node which is stored in first node. Linked list elements are stored at non-contiguous location. You are observing here, these are the random addresses in linked list. But in case of arrays, you have observed these addresses are continuous. These all are having increment of 4 bytes. Since we are using int array here, so it is incrementing by 4. In C++, size of int data type is 4 bytes. This is called continuous memory allocation. But in case of linked list, we have random addresses and thus we cannot use indexes in the linked list. Since there is no indexes, we cannot perform binary search in linked list using indexes. We have compared our linked list nodes with train coaches, but still our train engine is remaining. So what is it? This is our linked list main thing, which is compared to linked list engine or compared with train engine. So we have seen that our nodes are storing address of other adjacent nodes. But what happens in case of first node? Where is the address of first node is stored? So here we have this head pointer. we have named a pointer head and is storing the address of first node. Head is just a pointer, not a node. Head is used for referencing to first node. If our linked list is null, then head is going to be null. You can see at the end of linked list we have null here since there is no node after it. Also, in case of linked list, null determines the end of linked list. Now let's see what are the types of linked list. Singly linked list, doubly linked list and circular linked list. In singly linked list, we have one data part and one pointer part. We have discussed these things so far. So it is storing the address of next node and first node's address is storing in this head pointer, and first node is storing the address of second node is storing the address of third node, and so on. Null determines the end of singly linked list since there is no node after it. Let's see doubly linked list. As the name defines, doubly linked list is going to have two pointer parts. One data part here and one pointer part is for storing the address of previous node. Second one is storing the address of next node. Since in case of first node, we don't have any node previous to this, so we are storing null here. Always remember head is a pointer, not a node. So head is pointing to our first node and storing its address into it. Similarly like singly linked list. Now you can see this is our first node, this is our second node, and this is the address of second node. First node's next node is this one, and so this is storing the address of second node. Now what is in the case of second node, our previous node is the first node, so it is storing the address of first node, and its next part is obviously the third part. This goes on till end. You can see here, and at the end we don't have any node next to it, so we are using null here. You're observing two links between this. In singly linked list we just have one link since we are only storing the address of next node, but in case of doubly linked list we are storing the address of previous node and also the next node, so that in the doubly linked list we can print our linked list in reverse order and we can access the previous element very easily compared to singly linked list. Now let's see what is circular linked list. Circular linked list is somewhat similar to singly linked list, but in singly linked list we have null here. But obviously as the name defines, we are going to have some circle here. So we have replaced this null from first node's address to form a cycle into this. You can see there's a link is created between fourth node and the first node. This forms a cycle in the circular linked list. So that's all for this tutorial. We will discuss more about these types in further tutorials. Thanks for watching the video. If you like the video, then like, share and subscribe.